Hello, this is Jarrett, and then this is Henry. Today we're going to be working on an 06 Suzuki Grand Vitara, and it's a 2.7 liter. We're going to be working on the EGR and the PCV labs.
Okay, so with some pieces that we just found in the back of the car, we've decided to set up a little, diagram to show how some of this works. This is our EGR heat riser. This end right here would connect to your exhaust manifold, which this is upside down. This is our intake manifold. Your exhaust manifold would be somewhere kind of over here. This sits right here, and exhaust gases go through this tube into our intake, into this section. This is a sectioned off part of the intake. This does not go into here. This goes around to this port right here, and this is where our EGR valve sits right here. If you can see on service data, this is kind of a similar view. It sits right there and is what controls the amount of exhaust gases we recirculate. Using 2-stepper motors and a PCM control, it will allow a very small or a larger amount of gas to recirculate from this port right here around into this port, which goes straight through into our collector flange on our intake. So it'll go in, it'll flow through, and it'll go through the ports and get reburned by the engine. That's how the EGR works. Now, we're going to shift focus and look at the PCV valve, which is this section of vacuum lines right here. So if you want to come over here and take a look, that's kind of what our PCV valve looks like. So it's not very big, it screws in, and according to our service data, it does have a check needle inside the valve. So the rattle test that can work on it, and it is a variable flow type, at least from what I've been able to gather. It would sit right here on this valve cover and allow their crankcase vapors to go in through this tube into this hard line right here, which will then split it off into one of 2 ports on our intake, either this lower one or this lower one over here. And from there, it goes into the same kind of collector part of the intake, back through, and then up and gets burned by our engine. So that's how the EGR and the PCV valve work. Okay, so once again, this is the 2.7 liter V6, and now we're going to show you on the vehicle where each of our systems lives. So to start with, there is our heat riser or gas riser, I should say, for our EGR valve, apologies. It runs right up there to the back of the intake manifold, right there. And then our actual valve lives just underneath and behind our throttle body, which is why I decided to show it off the vehicle before, because you can't really see it once you're here. But those yellow and blue wires back there are the connector for it. As I'm trying to focus on it, there we go. And then our PCV valve, as mentioned, lives on this valve cover. It is that hose right there. Enhance. There we go. You can kind of see, no, you can't really, but it's right there, that hose, and then it connects into our vacuum lines right there. And from there, as I mentioned, it runs up and to right there. Okay, so now what we're gonna do is show the negative pressure inside our crankcase caused by the PCV system. This is a basic test that just about anybody can do. And what we're gonna do is right here, this is the air inlet into our crankcase. It connects right here into the fresh air intake. So I'm going to start the vehicle, and we should have a little bit of vacuum right here on this hose, and I'm gonna demonstrate that by using a $1 bill. We're gonna hold it up to it. This is legal tender, not counterfeit, and you see right now with the vehicle off, it's not gonna do anything. It's just gonna fall off. However, if I start the vehicle, you will see that if I take a $1 bill, or if any piece of paper, really, it doesn't have to be a $1 bill. $1 bill is just something easy everybody has on them. And I hold it over this, it should be lightly sucked to it. It might take a minute here for it to start blowing some vacuum, but if I hold it over it, as you can see, the vacuum in it is holding that piece of paper to it. And you can hear as I let off of it, it does make a little bit of a sound. You can hear it just suck air in. So our PCV system is functional on this vehicle.
Right now we're going to be looking at some of the PID values that we have from the car without the EGR, any of the EGR actuating or any of that. As you can tell right now, the EGR valve opening is at 0%. From the other readings, like the MAP sensor, it's running about 3.78. Engine speed, we're running about 840 something RPM. MAP sensor is reading about 4.06 PSI.
And then we're also...
Yeah. For the short-term fuel and the long-term fuel.
Lean.
Yeah.
Which
just
makes sense
bit.
because our mass airflow is a little higher than we would expect at this RPM with the 2.7 liter.
And then with the ECT, it's running about 145 for the temperature, and that's around normal because we just turned on the car. Right now it's just barely idling, warming up, and yeah.
Okay, so right now we are in a different scan tool in our active tests, and I have commanded open our EGR valve a little bit. As you can see, our manifold pressure went quite a bit up, as well as our airflow rate has come down a little bit. And as I increase it more, let's see if it allows me to increase it more. It may not. But you can hear the engine. There you go. I can decrease it a little bit. Our airflow rate, it doesn't change a lot, but our manifold pressure changes quite a lot. And then if I decrease it all the way back down to 0, which hopefully it should, it will, maybe not, maybe it doesn't want to. There, I can increase it to 24, manifold air pressure goes up. I can decrease it, manifold absolute pressure drops down quite a bit. So you can see that we are actually fluctuating with our EGR valve opening. So this here is an example of a PCV valve. Now this is not off of the car that we were showing before, the Suzuki. This is off of an 06 Toyota Camry, but it's a very similar design. It's basically identical because it is a variable flow type that screws in, and you have a hose that connects right here.
This one was just easier to get to.
Yeah, this one's just a lot easier to take out to show. And now, if you shake it, we did a little test. You probably won't be able to hear it on the video, but if I shake it, you can hear the valve move back and forth. Now that doesn't mean it's good, but it means it's not immediately bad. Because if you shake it and it doesn't make any noise, it's probably gunked up. Now what we did do, and I'm not gonna do it on camera, but what we did do is try and blow air through it one way, and it blocks air. But if I suck air through it, it'll pull air through. So our valve is seating correctly and is functioning on this vehicle. Okay, so on this vehicle, again, this is an 06 Camry. I'm just gonna put it back in and show you guys where it lives. It goes right here on the back of our valve cover. So we have our fresh air inlet up here and our PCV outlet here. This is the hose that connects to it. And this just screws in right here. And now what you do is put it in, and this is a 22 socket size, 22 millimeter. You're gonna screw it in and then torque it to 14 foot-pounds according to all data. What I'm gonna go ahead and do is demonstrate what would happen if, say, this line right here were to either break or tear, or you just don't hook it up. You can hear the engine's running beautifully, running on all 4 cylinders. If I go ahead and disconnect our PCV vac here, now this line connects straight to the intake, so this is gonna create a massive vacuum leak. If I go ahead and unplug it, you can hear the engine basically dies. And when I replug this line, the engine comes back. If I take it off again, you see it really struggles to run, and it's running on probably not quite all 4 cylinders anymore.